3,000 meters below the surface, sunlight is a distant memory, and the ocean is a pressure chamber that would crush human bones into splinters. At this depth, the water presses inward with a force of over 400 atmospheres. Imagine a dozen elephants standing on every square inch of your body. It is a world of perpetual night where temperatures hover just above freezing, cold enough to stop a heart in minutes. We have mapped the surface of the moon and sent rovers to Mars, yet we have explored less than 5% of this abyssal realm. We often think of the deep as a graveyard, a silent void where life goes to die. But the reality is far more unsettling. It is a realm of titans and alien architectures where the rules of biology we learned at the surface simply do not apply. In a world defined by the total absence of light, evolution has had to get creative. For most creatures, the normal way to see is through a centralized brain and two eyes. But in the deep, the octopus represents a fundamentally different blueprint of intelligence. With 2/3 of its neurons distributed throughout its arms, each limb acts as a localized processing center capable of tasting, feeling, and making tactical decisions independently of the central brain. The visual systems here are equally bizarre. While humans have a structural blind spot in our eyes, the octopus eye is a masterpiece of convergent evolution. It has no blind spot, and its neural wiring attaches behind the retina, an engineering feat that would make a human designer envious. But it's not just how they see, it's what they see. The dragonfish has evolved a private searchlight. It produces a red bioluminescence that is invisible to almost every other creature in the deep. It can illuminate its prey while remaining perfectly hidden in the dark. Other predators, like the black swallower or certain deep-sea fish, are cloaked in ultra-black skin that absorbs 99.5% of all light, making them effectively invisible even when a submarine spotlight hits them. To understand why these monsters exist, we must look at the physics of the deep, where a phenomenon known as deep-sea gigantism is driven by the extreme conditions of the abyss. Temperatures here hover just above freezing, which acts as a metabolic asset rather than a death sentence. This slow burn slows the chemical reactions that power cells, allowing giants like the isopod, a relative of the pillbug that grows to the size of a small puppy, to survive for over a year without a single meal. This growth is further supported by the oxygen advantage of the deep, as cold water holds significantly more dissolved oxygen than warm tropical seas, effectively removing the biological ceiling on size and allowing immense tissues to function without suffocating. Furthermore, at depths of 4,000 meters, the ocean acts as a sculptor favoring larger bodies. Because these giants, such as the colossal squid with its basketball-sized eyes, possess a lower surface area to volume ratio than smaller, more fragile organisms, their internal structures remain more stable and are less distorted by the crushing weight of the midnight zone. In the deep, size isn't just an advantage, it is armor. Perhaps the most abnormal thing about the deep sea is how it connects to the rest of the planet. We think of it as isolated, but it is a planet-level engine. Sperm whales dive into the abyss to hunt giants, and when they return to the surface, they fertilize the ocean with nutrients that drive the growth of plankton, the foundation of half the oxygen we breathe. When a giant falls, it creates a whale fall, a biological oasis where a single carcass can feed an entire ecosystem for a century. From bone-eating worms to scavengers that have remained unchanged since the age of the dinosaurs, the deep sea is a living memory of the Earth. Every creature in the deep sea, from the Greenland shark that can live for 400 years to the snailfish surviving in the 11,000-meter deep Hadal Zone, tells us the same thing. Life finds a way to reinvent itself. But even this remote frontier is no longer a sanctuary. Scientists have found plastic fibers inside the bodies of amphipods at the bottom of the Mariana Trench. It is a sobering reminder that our footprint is now deeper than our knowledge. There is a concept in science called the Umwelt, the unique perceptual world of an organism. A human's world is built on light and symbols. An octopus's world is one of distributed sensation and autonomous limbs. If life can adapt to the crushing, toxic dark of our own trenches, it suggests that the icy moons of Europa and Enceladus might not be empty voids, but home to minds we can barely conceptualize. The deep sea proves that intelligence and survival don't follow a single script. It is a reminder that when the environment is extreme enough, the monsters of our myths are simply the most logical solutions to the problem of staying alive.